So welcome to our third segment in our EMUE ACE webinar series. So presenting today, my name is Mike Harris. I'm the lead EMUE trainer and analyst here at Databound Solutions. And Oliver St. John, who is our technical lead and analyst, is helping me out with some of our host functions today. So thank you, Oliver, for being with us.
You're very welcome.
So today's focus is on algorithms in EMUE and some of the ways that we can implement algorithms into our scripts to make them a little bit better, a little bit quicker, and a little bit easier for us to read. So for our focus today, we're going to be talking about for loop processing, call statements, which also go with returns, global versus local variables, and algorithms. So we have some examples of some algorithms that we put together. And to start, we want to talk about the definition of an algorithm, because usually when people hear the word algorithm, it brings up a lot of different thoughts. So we wanted to clarify what we're talking about when we talk about an algorithm. That first definition is in mathematics and computer science, an algorithm is simply a self-contained, step-by-step set of operations that are to be performed by the computer. They exist to perform calculations, data processing, and automated reasoning. The informal definition is that it's any well-defined computational procedure that takes some value or set of values as input, produces some value or set of values as output, and it's thus a sequence of computational steps that transform the input into output. So it's pretty simplistic when you look at it that way, and all of you on the call most likely have written a script that does exactly that. You take some input from someplace, whether that be a list of patients, whether that be a list of files. You do something with that data, and you output it. So without knowing it, you were most likely already writing a form of algorithm, but maybe didn't call it that. So one of the common things that I hear when I talk to people about algorithms is, well, don't I need to know math to create an algorithm? Isn't that what an algorithm is? It's some type of math thing that people use. And the straightforward answer is no, not really. Typically, algorithms, it's more of a path of execution than a mathematical execution, and it results in a usable programming product that we can use for a variety of things. This can be mathematical formulas, but it actually depends on your programming need. And the algorithms themselves are more concerned with the steps than the math behind it. So I thought I'd start out today with some common algorithms to show you how we're actually surrounded by algorithms in our everyday lives. The first thing that we're probably used to is processing strings. And one of the best processors of strings is spam filters in email. They look through your emails, they see if it's spam, and if it is, they plop it in your spam folder, or if you're using the new Microsoft, it's your clutter folder. Also processing numbers. So things like news feeds. So if you're on Facebook, Twitter, things like that, they actually use algorithms to figure out how many things were liked, how many times things were viewed, and they put those into your feed. We also use number processing for traffic lights. So how many cars are waiting at a light if it's a pressure sensor, or how many seconds have gone by before I need to change and flip over. And they repeat these hundreds and thousands of times a day. Cybersecurity is another place where algorithms are used heavily, and one of the most common is the RSA algorithm, which encrypts and decrypts information. And then there's the internet, of course, search engines. Google is one of the most famous algorithms out there, and link analysis, so linking to see where links go. And last but not least, reducing repetitive code, so processing users and member data, which is something that we do in healthcare on a regular basis. So translation to EMUE. So when we're using algorithms in EMUE, it's fairly straightforward, but there are some things that we need to think about when we're transitioning just a task that we would normally do manually into an algorithm that we can reuse in EMUE. So for an example, if I need to find users that have X property, such as a social security number or name or accounts receivable amount due, then I need to perform Y process on them. And at the end there you see ready script, because that's a lot of times what we want to jump into. It's like, I have this problem and I want a script right now to solve it. Really what we need to do step back and think about our process. So our steps then become what's listed below. First, we need to take a look at the process needed. Once we've identified what we need to do, we need to look at the steps to complete the process. We need to write out our logic, and then we need to write our algorithm code. So when we're writing algorithm code, the key to really being successful here is to first write out the logic, and usually I tend to do this on pad and pencil so that I can erase things, I can draw new lines, and I can see visually what I'm going to create. You can also do this in visualization products like Visio and other things that allow step-by-step logic. So we're talking about algorithms at work. This is typically what one of our flows would look like. We log into a website or a terminal. We call our get patient data. We process our patient data. We create an output, and then we would exit our process. When we think about algorithms, we're thinking about the pieces that are in between. So when we call the patient data, we're going to go someplace in our script, do that process, and then come back to where we called from. When we process our patient data, it's going to be the same thing. We're going to go to some separate section, then come back. And then when we create our output, we do that and come back to our exit. So we're actually going to separate parts of the script instead of going straight top to bottom, which is what most people are used to when they're scripting. And for those of you who have done additional programming work, so if you've worked in C# or Visual Basic or a lot of other object-oriented programming languages, you're used to the terms global and local variables. And what those mean is you have to be concerned that your variables are in scope or within the section of code that you're dealing with. And global variables typically exist throughout the program, while your local variables are short-lived, temporary pieces of information that go away once you're not using the method or the function that you were using. In EMUE, though, all variables are global. So if you change a variable in one spot, it's going to change the value of that variable throughout your code. You don't have to worry about, is my value local or is this global? It's all global. So you can be assured that when you're using the same name, you're always getting the same value. So for those who have programmed in another language, this is just something to be aware of. And if you've used EMUE at all before, this is something you've probably experienced. So not a huge concern, but something worth mentioning. So here's some commands that we're going to go through today and talk more about. This slide is more for informational purposes. I'm not going to go through each one here. We'll go through those a little bit later. But you can see there's a few on here that you should be concerned with. So let's take an example from EMUE, and this is an example of reusing an external script. Now, some of you may have had experience with other scripting languages, such as Python, Perl, drawing a blank on some others, but there are a lot of other scripting languages out there that you could have used. There are also products that you can use from the command line that do certain pre-processing for you, such as Monarch, which processes data files through automated processes. And you may have already written these and not want to rewrite all of this code that you've written. And if it's an automated process, the good news is that EMUE can use an algorithm to run that for you and get that data back. So let me switch over to EMUE real quick so we can take a look at this. So here I have my EMUE script, and I'm just going to start this script up real quick. And this first line, which is one of our commands that we're going to be going through today, is called our run command. Once we've logged in and got here, you can look at line 84, and you can see reusing external scripts. And the next line below that is run command. Run command is one of the commands that we're going to talk about today, and this takes two parameters at minimum, well, actually one parameter at minimum, and the run command itself, as well as two optional parameters here called hide and wait. So when I run this, you're not actually going to see anything. So what this is going to do is it's going to create our input file for me. And the analogy here for you would be pre-processing any type of information that you were going to use on a repeating basis. So we get into our input files folder, nothing in here. When I step through the process, however, it takes a second to create. and then it's going to have my information in there. So now I have a test input file. And if I were to read this, you can see that it's just a list of patients. So the value in that run command is that you can actually use a script that you've already written without having to go out and rewrite an EMUE script. So I'm going to test that it exists, and if it does, I'm going to set my input file to it. Once I've set my input file to it, I can do whatever I want. So by using this simple syntax right here, I can reuse other scripts that I've already written. So we can integrate EMUE's automation capabilities with existing scripts without having to write a batch file, without having to write other automation for those scripts. You can do it right here in EMUE. So using the tool that you already love, let me go back to the PowerPoint. And let's take a look at some of these commands. The first one is our for loop. So for loops give us some great functionality. At the basic level, it's used to iterate through a set of script statements for a specified number of times. So that X that's up here at the top actually represents a number of times that we want to execute through this statement. There are a couple of notes when we're using for loops, and you may not have ever run into this, but this is something to look out for. The first thing is we cannot use a goto while we're in a for loop, because that effectively breaks out of our for loop function without cleaning up after itself nicely. So it will give you an error for that. Next, we can't use nested for loops if they're a simple for loop, which is what this is. So we're saying for 10 times do something. We don't have any other control over it. We do have more control in a structured for loop, which we'll go through in a minute. The last note down here, and this is actually something I learned when I was creating this PowerPoint, is that you can use an asterisk to make the loop repeat infinitely. In other languages, this is synonymous with a while loop. So while we're doing something, keep going. So you could use the for star to create an infinite loop that will go through as many times until you reach a certain point when you can break out of it. When you reach that point, you're going to want to do some additional functionality, which we'll get to in the next slide. So here's an example. So let count equal 0, for 10, let count equal count plus 1, and I'm currently on loop count. Very simple. If you plug this into EMUE and ran it, all it would do is it would count to 10, and it would say, I'm currently on loop number 1, number 2, number 3, etc. So if you're in your for loop and you put that star in there, I said it's an infinite for loop, we want some way to get out of it. And that's what break will do for us. We use a break to stop ourselves from continual execution in a for loop. Some things to be noted here. You can't use a for loop with a structured for loop. And this will break down later on in the slide so you can see a good comparison between the two. The next thing is it's useful for testing a condition and exiting a loop when a certain circumstance or circumstances are present. This exits the loop and will not continue executing any additional commands within the loop. So once you've broken out of that loop, you can't go back and process additional patients if you were processing a patient loop. You can see the example here, for star, let count equal count plus 1, and if count is greater than or equal to 5, break. And you can do this one as an inline statement so that you don't have to break it out into if, then, and if, etc. And then this one would say, tell I'm currently on loop number such and such. So this one would go through, and as soon as it reached 5 and was equal to 5, it would break out of that loop and stop processing. So you would get, I'm currently on loop number 1, 2, 3, 4, 5, and then it would break out. The syntax for this is simply break. I could have changed this code to say if count is greater than or equal to 5, then, and on a separate line written break, and then end if as well. But the inline statement's pretty easy. And I did want to call attention to one comment that David Button had, which is great. You can't go to, but you can call in a for loop. And when we get to our call statement in just a minute, that will come back again. So great point, David. I'll come back to that. Our next statement here is a structured for loop. And this, I want you to think of a structured for as a more powerful loop that gives you more control of the things that you can do. So this is used to iterate through a set of script statements, just like a regular for loop, but it gives additional control and flexibility. So some notes. The start and end can be specified. So if you look at this slide, at the top you have for x equals y to z, dot, 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 next x. The dot, dot, dot is where your statements will go, and we'll see that in the example in a second. But if you look at y and z, that would be a number to a number. So for example, 1 to 10, and we'll see that in an example. So here we have for x equals 1 to 10, and then for y equals 1 to 10, do something. So this is actually a nested for loop. The next point down there are the other notes. We can use step to specify the size of each iteration. That would actually go to the right of the for loop, so it would say for x equals 1 to 10, step 2, for example. What that does is it allows us to tell EMUE how many increments we want to go at a time. So instead of counting 1, 2, 3, 4, 5, 6 all the way to 10, it would say 1, 3, 5, 7, 9, and then it would end the loop because it went beyond 10. You could have it do 5, you could have it do whatever number you like, but it could skip over. Next, we can use the continue keyword within this iteration. We'll talk about continue as well because that's something that's useful for algorithms as well. You use the exit for in this instead of the break command. So earlier we said for loops or simple for loops, we can use break. For structured for loops, we would use exit if, or exit for, excuse me. These can be nested, and the index and step may be negative numbers. So you can work backwards through a list by using negative numbers. If you said for x equals 1 to negative 10, step negative 1, it would step backwards through your list. So your syntax listed here is for an index equals your start to your end, and then in square brackets there, square brackets again meaning that it's an optional parameter. You see step, and then in the angle brackets, the step would be a numeric value. You have one or more statements, and then at the very end of your for loop, you have a next. And that next is going to tell you to go back and get the next indexer for that loop. So if I'm dealing with x, for example, up here under for x, when I get down here to the bottom, it's saying, give me the next x in this loop, and keep going. So let me pause and go back to EMUE so we can see this in action. And I'm going to skip around a little bit. So we have a for loop here, and you can see this for patient equals 1 to patient count. We're going to come down here, and we're going to get this information. So however many patients are on my list, it's going to do all of this process. I'm not actually going to run this at this moment because there's more code that depends on, or this depends on. But when we get back to it, you're going to see this for loop execute all of these statements over and over for the number of patients that are in my list. Next is the word continue. This again is used for structured for loops. This stops the current iteration of the for loop and goes to the next one. This is useful for skipping records that match a certain criteria. For example, when you're filtering through a list of patients and you get to a patient that perhaps doesn't have the right information in their file. So if patient name is blank, then continue. It skips that patient and it goes back up to the top and processes the next patient. That allows you to do all of the rest of your list while skipping any records that don't meet the criteria that you're looking for. Simple for loops cannot use continue. At the bottom, when processing patients, having a continue statement can be used with a logical test to avoid circumstances that could cause an error. So you could see that example down there, last name equals blank. So for x equals 1 to 10, If x equals 5, then continue. What this would do is, instead of printing up until 5 like we saw earlier, this would print 1, 2, 3, 4, 6, 7, 8, 9, 10, and it would skip that 5 variable. And the syntax is simply continue when we put it in line inside of a structured for loop. Exit for, we talked a little bit about this. So it cannot be used in simple for loops, and it exits the structured for loop even if it's nested. So be careful with this one, because if you're trying to exit the inner loop to get to the outer loop, exit for will exit everything. The syntax for that is simply exit for, and you can see that this is very similar to the continue. We put it in the same spot. The only difference is when I run this code, when I get to 5, my exit for is going to tell me to get out of here. So it would print 1, 2, 3, 4, and then I would exit. My syntax is simply exit for. When we use the call command, what this is going to do is it's similar to calling a function in other languages. It's used to stop where you're processing right now, jump to a different section of the script, process that section of the script, and then come back to the very next statement under the call. So we use the call command to redirect script execution. Under other notes, number 2 is useful for creating reusable code, and we'll see that in just a minute. The calls can be made from anywhere in the script. And there's a little note down there for that note that says calls from within a simple for loop cannot reference script that contains other simple for loops. So you can see that it's like nesting, and we can't nest simple for loops. So make sure that you don't have a for loop where you're calling to, or else it will throw an error for you. The reason for that is we get to the end of a for loop and use the end for, it ends the processing of all of the for loops that were coming before it. So when you go back to that original for loop, it doesn't know where it is. The syntax is really simple, and this makes your code super readable. Call and my function. So my function would be the name of the label that you're trying to go to. And then once you hit this, it will go to your label, and then we'll come back. There's one more that I want to go over, and then we'll go to our EMUE script. That's return. Because anytime we call to a label, we need a return statement in order to return back to the line after the call. So notes on that, you must have a return statement in the body of a function that is called with a call command. And if a return statement is encountered, it will return execution of the line after the last call statement that ran. So this is the syntax for it. Call my label, and then you have other code underneath it. My label down towards the bottom, and then return. And the syntax is simply return at the end of your called label. Now, how this actually processes is you go from call my label down to my label, and then once you hit the return statement, it's going to come back up here and start processing the other code. So before we do the run command, let me go back to EMUE, and we're going to see this at work. So we're going to create a list, and we're going to go through this. This is an example of a small algorithm that you're probably already familiar with. You probably didn't call it an algorithm, but what this is doing is you're testing if you're at the end of the file, and then you're going and doing some process over and over again, and then you have a go-to at the end. So this simple loop does something repeatedly that you can move between scripts if you wanted to. I'm going to put a breakpoint right here, and I'm going to run this. And we've run through that. And so now if I go to input list, we have a list of all the inputs from my file. It was quick, and because I put it into a compact section, I can understand what it's doing. I can also do the same thing with a call statement. Here you can see using modular code and creating a call structure. So if I make this my current script line and I step through it, I'm going to go down to create list structure. And you can see I have some reusable code here. The nice thing about building algorithms like this is that I can take this create list structure function and I can put it in any scripts that I want to. And as long as I just change and tweak the path a little bit, it will be perfectly fine and it will run every time. So I copy my Excel path, I do my query, I get my data, I remove my blank list numbers, I create my success to my error list, and then I hit return. So I called down to this function, and when I hit return, you can see I go up to get list count, which is the very next line under that call statement. The nice thing about calls is that I could do call create list structure, and then I could do another call below that, and a call below that, and a call below that. And as long as I used returns, I would use call instead of putting that code in there and having to loop back to that code every single time. So let me come back up here to the top, and I'm going to show you a fun little algorithm that was online. This is reversing an integer. And honestly, I couldn't tell you a week ago what reversing an integer was, and thanks to Oliver, I have an explanation. So in some languages, it's very difficult to work with integers and pulling individual pieces off of an integer or out of a number. So by reversing them, you can get the last digit by pulling the first digit. If you know C# or Visual Basic, this code down here will actually do the same thing. So let's take a look at this. I'm going to show my variables tab down here. All I'm going to do is I'm going to get some user input, and I'm going to put in a number that we can easily notice is going to be reversed. When I click OK, I'm going to set a variable to my user. I'm going to get the length of that number. I'm going to get the left length of that number, and I'm going to copy a blank string into a reverse number. So I'm going to use these variables to switch my number around. And now this is actually my algorithm right here. So you can see I'm using a for loop, and I'm using the length of that number. So I got 9 digits. And we can verify that down here in our variables tab. And all I'm doing is I'm getting the right number. I'm pasting it onto my reverse number. I'm subtracting 1 from my length, and then I am getting the leftmost digit out of there. So as I go through this, if I put a breakpoint in there and run, each time I run it, you can see reverse number down here adds number to it. But you can see now my reverse number is 987654321. That's an example of using an algorithm to do something that I might have to do over and over again. Now, admittedly, reversing a number isn't something in the healthcare field that we're going to have to do every single day. But that concept of using repeatable code is. So let me come down here to the next section of using a for loop. So we already have our patient count. So we can look at my list, and I have 6 people here. And if I run my code for my for loop, every time I go through, you'll notice that I'm using several things in here from our previous slide. So first, I'm using this structured for loop. So for patient equals 1 to patient count, which is 6. I'm going to do something. And you can see next patient. As we're going through, this patient number is going to increment. So patient number 1, patient number 2, patient 3, patient 4, patient 5. So I could use patient as a variable in my code in order to tell me what loop I was on, or in order to tell me where I failed in code, something like that. So as I get in here, I do a get list member, and then you can see call format patient name. Now this is a pretty short section of code, But when I call format patient name, I come down here, and if you look, format patient name is pretty long. And I'm sure you can think of one of your scripts that has a large section of code that you repeat over and over and over again that you could pull out and just do a call statement. Because if we're reading our code and we look at call format patient name, I know that I'm going to be formatting a patient name. And so I can just read through and say, all right, I'm doing a function to format my patient name. I'm coming down here, I'm copying some information, and I'm doing something else. So if I run through this code, all I'm doing is formatting this information. And this little, the code to format a patient name is on our form as well. And then when I hit our return statement, I come back up here, and I'm going to copy patient successful true. And in between there is where your code would go. So if you have to do other things with the patient before logging success or failure, do so on line 6061 in that area. For this next section, again, I was going for readability with my algorithms here. I could have done log success, all of the steps to log it here, but it wouldn't have looked as readable as saying, if the patient success equals true, then log success, else log error. Anyone looking at this code could have told me what those supposedly would have done, at least in theory. So obviously patient success will equal true because I set it to that up here. I'm going to call success. And if we look, it's only 5 lines of code altogether, including my return statement. But by doing it this way, I can use log success and log error in other scripts and just plug in the call log error and log success within the script to plug it in there. So instead of having to write 4 or 5 lines of code, I just copy, paste, and it frees up a little bit more of my day. And then we go to next patient. So I'm going to put a breakpoint here, run this information, and quickly get down to call export lists. So again, if you look at this tag here, this command here, export lists, probably means that I'm going to export my lists to someplace. And in fact, when I run this, I am simply exporting them to Excel. 2 lines, but again, I can copy and paste this call and that function into a new script without having to rewrite it, which means that I save time and energy when I'm writing my scripts. Let me pause. I'm going to go back to our PowerPoint real quick. Earlier we talked about run command. The run command is really useful and really powerful because it emulates the run function that you have in Windows. We're able to run Windows-based programs through EMUE. Some notes on this is that it's useful for using programs that have already been written to perform a function. EMUE can wait for the application to finish processing for either waiting forever or it can wait for a specified amount of time. You can also process things without having EMUE wait. And in that case, you're creating a parallel processing structure so that you can process multiple things in parallel to create or to finish your task quicker. Number 3 there is exactly what I just said, to execute in parallel. And the last note is just a caution. Be careful, though, if you're going to run this to use parallel processing, because if you start processing too many parallel threads, it can slow down and possibly crash your computer based on the resources. So if you're only dealing with 1 gigabyte of RAM, it's probably not a good idea to run 30 different things all at once. The syntax for this is really easy. It's simply run command, the file to execute, and then we have several optional parameters at the end. So window style, wait type, and timeout. Window style allows us to have a minimized, maximized, or in this case, a hidden window. The wait type is either to wait or not wait. And then timeout is an optional parameter that allows us to say how long we want to wait for this application to complete. If I say wait with nothing after it like I have here, it's going to wait forever for that script to finish processing. If you say wait 15,000 milliseconds, then it's only going to wait for the 15 seconds that you specified and continue on after that. Typically, I would not recommend using the wait with no timeout if you're running an outside program, because if that outside program crashes, then EMUE will wait there indefinitely, and that's probably not a desired behavior. You'll notice one other thing that I want to mention about command. If you look in between the double quotes here by run command, you see Python space C : /myscript py. You would put your parameters in this double quoted area just like you would into the run command. The only thing is, if you normally use double quotes around something, such as C : /myscript.py, you would change those to single quotes in order to conform with EMUE's scripting language. The next command that's pretty similar is our run EMUE script. This gives us the power to launch another EMUE script basically the same way that we launch another program from EMUE. So first note on that, it's a powerful way of executing multiple processes from one script. So you can have one script to rule them all, so to speak. There's no limit to the number of run EMUE commands that are executed per script, but there may, based on license or physical machine limitations, be limits on how many you should or can run. So I can run 3 scripts and then pause, and then run another 3 scripts and then pause, and so on and so forth. And this extends the user's ability to script for reuse. So if I have a script that processes patient data, and I want to use that, and then I also have a script that pulls out verification that that data was processed correctly, I can use that. And then if I have another one that creates a nice looking report and sends that out, I can use all 3 of those scripts in one script by using the run EMUE script command. So I could run my first EMUE script that processes it, my second EMUE script that verifies it, and my third EMUE script that gets the reporting data. And in that case, I would want to wait just like I did before. And in this case, you can see that I have my wait type of either wait or no wait, and then a timeout that's listed in milliseconds. So in this case, my run EMUE script would wait 60 seconds for my EMUE script.EMUE to complete processing. And the last one here is go to script. Go to script is a different but equally powerful way of using multiple scripts. While run EMUE script launches multiple scripts from one script, go to script can use multiple header files to use one logic script. And what it does is it gathers variables and settings from one script and uses them in another. So the notes on here, it redirects EMUE to another script, and relatives paths will be relative to the original script location. The syntax for this is very simple. Go to script, C/EMUE, my script folder, and my script.EMUE. So it's simply the command and then the path. The script file name and path. So if I go back to my EMUE script now, you can see I have go to script listed here. If we look down on our variables tab, we have a bunch of variables listed. We have our lists. All that stuff is still here. If I step through this, I'd like everyone to watch up here in this title bar area. You'll see Webcast 3 using algorithms and EMUE debugging. When I step through it, almost instantly, we've gone to a new script. You can see this one is much shorter. And you can see an arrow at the end pointing to my new logic script.EMUE. And up here at the top, all I've done is I've copied several pieces of information. I am using that same algorithm that I used before to process the patient name. And I'm going to go through this. And as I'm doing this, you can see down here at the bottom, though, I still have all of my variables from my previous tab. and all of my lists. So even though I did not create a list in this new script, all of my variables, and if you look behind the scenes, all of your settings transferred to this new file. We use this here extensively when we want to write scripts for different hospitals that use one same logic script. So what we'll do is we'll create all of the variables that are important to that hospital. So the hospital name, hospital location, et cetera, and then we have a logic script that does not have any settings listed. So if we look at this script, there's no settings here. All it is just pure logic. What am I going to do with the data that I'm handed? And so I've handed it lists, I've handed it variables. I can even hand it input files if I want. And what it does is it processes through the logic that I've created. So multiple scripts can use the same logic file with GoToScript. And when I do this and exit, you can see both scripts have gone away. So technically, I'm only really looking at one script at a time, but it switches back and forth quickly. Now I want to take a look and recap on some of the stuff that we've talked about. So simple and structured for loops. A simple for can use for, end for, and break. It's good for looping a known number of iterations. Can be used to create controlled infinite loops, and not used for loops where control over individual executions of the loop is necessary. Whereas structured for can use the for x equals y to z step n, where x, y, z, and n are integers or integer-containing variables. Next, var_name, continue, and exit for. These are good for controlling and testing each iteration of the loop using the iteration variable, x in the example above. They're useful for skipping records based on logic tests, and these can be nested. So this is in here for your reference if you download this PowerPoint. And there are some tips for implementing algorithms. The first step of the process is designing your algorithm. So planning your process and looking at what you need to accomplish. Next is to map each step of the process prior to scripting. Loop for repetitive pieces of code or process that can be condensed. So any types of loops that you can create, think about when you can pull that code out of your script and create a loop for it. Write your script, debug your script, and then implement your algorithm. And last but not least is reuse your code. Once you've written a great piece of code that's generic, take it from one script, put it in another script. It will mean less time scripting, more time tweaking and making that script perfect. So now I'm going to pause and see if we have questions or what questions everybody has. And Oliver, did we have any questions while I was talking?
One question. Yeah, we've had a couple. Oh, yeah, just quick question that just came through from Petra about nesting calls. Whether you can nest a call within an already called function.
It's a great question, Petra, and the answer is yes. As long as you return properly from your calls, you can nest calls. I wouldn't get too deep with them because it can get confusing, but yes, you can.
We did have another question from David that about a half hour ago about the difference between exit for and break, one of them being for simple for loops, whereas the other is for structured for loops, which I know you covered on your last slide. Mm-hmm. Also definitely a great question. And looks like we just got one more question in from Petra about a GoToScript, and is there a recommended folder structure where this should be?
That's a good question. Typically, if I'm using a script as a logic script, so the way you can think of this is kind of like a funnel. You have all of your header scripts and the one logic script. The one logic script I would put in a centralized place, and the calling scripts or the header scripts where I'm going to gather my settings and my variables, I might put those in their own folders so that I can find them and keep the logic script in a centralized location so that they can all access it with the same pathway. Makes it a little bit easier to keep track of.
This is Dave Button.
Dave, how's it going?
Can you hear me? Hey, good. So a question that you just mentioned a second ago about the call. So if I have a nested call, so I'm calling to one function, and then within that function I'm calling to another. So the child call returns back to itself, and then you're saying that the parent call will indeed return. The call stack doesn't get overwritten?
Correct. You would actually
okay.
add on to the call stack. And one thing I will show you, let me go back to this. Well, I can show you here. This is actually an example of our template builder, which is something we're looking to possibly put online to build templates easier. You can see I have a bunch of call statements in here, and I chose to use this for simplicity's sake. If I hit this call statement and I click this call stack tab, I would actually have a list of calls down here in the lower left-hand side where it would say the line number that called and the line text that called. So as I go through more call statements and call additional things, it would add to that call stack. And so this is actually a tab that is more advanced, and we don't talk about this in basic training because most people won't use call stacks very often. But you can review that information here. You can also clear your call stack if you don't want to return back through when you're debugging. So, but that is a very powerful button.
Okay, I had not visited that tab. That's good. Okay, great. Cool.
Good question.
If there's not another one, I guess I got another one.
Sure.
Let's see here. What was the? Oh, what was the function you called when you're within one EMUE script and you popped over to another one and it used the arrow up in the title bar? What was that function again?
That was go to script.
Go to script?
Go to script, yep.
Okay. Can you, the example that you mentioned, it didn't quite click with me. Do you have a different example of why I would use that you can think of?
Sure. So when I talk about logic scripts, it's mainly the larger piece of processing that you typically do. So for example, if I was working on a Saurian or an Envision system and I had I had a business office and I had an IT office, and they both had to use the same process, but they had to use different logins to get there. I can write a header script that included the login for my business office, and I write a header script that included the login for my IT department, and each one of those could call the same logic script with GoToScript, use the same logic to go through the process, but all it would do is it would change my login information in my settings. So for example, in terminal, maybe the CHPS or the CICS changes based on where I'm going to. I could put that information in my header script and then use the same called logic script or go-to-script logic script to process that data.
Interesting. Okay.
And
yeah, I guess I
actually
only have one entity that doesn't.
Yeah,
okay.
For one entity, it's not as useful, but
sure.
We actually had a response from Carlos Alvarez to your question. We use a lot because we have 6 entities and don't want to write scripts for each. So we use a generic logic as much as possible. So excellent. Thank you very much, Carlos.
Another very useful thing that we've at Databound is when if you're gathering, for example, if you have multiple clinics which all use a centralized billing system, then you can gather all the information from each one of those individually with a header script, and then each one of those can use the same logic script as far as the actual billing aspect of it.
Interesting. Okay, cool. Thank you.
Okay, great question. All right, well, if there are no more questions, I will call the meeting for now, but if you have additional questions that I haven't answered, there's a few different places you can find support on our website, our forum, or you can give us a call. You can also email me if there's a training question you have. But otherwise, thank you very much for joining us today.